Okay, today's lesson is a 4.2. They're still the same. There's an electromagnetic induction. Okay, I show my face already, so better you focus my face. Okay, so from here I go through to the first slide. Okay, we need to find the discrimination for the direction of the current by the galvanometer. So before that, we learn about got current to flow. But this round, we need to know current how to flow. Okay, let's see the deflection of the galvanometer pointer in a similar to the ammeter. Okay, galvanometer deflected the same like the ammeter because ammeter consists of a galvanode and also the resistor. In the ammeter, they got resistor, they also got the galvanometer. So that's why they can deflect it. Okay, so from here, we need to know the characteristic for the galvanometer. First, start from 0 at the center. Okay, 0 at the center. Okay, for this one, galvanometer, just now I told you that at the center is a 0. If they move to right-hand side, that one is a positive side. That means there is a negative. Okay, so one thing you need to know, you see the diagram first. Okay, we got the battery. Battery must start from the positive first. So you see the current that start to flow lah. Okay, when the current just flow to here, okay, you see the galvanometer. They always deflected to the direction where the current is. Okay, the current just in that direction, then the galvanometer will deflector go that directions. Okay, so that means this one, when it just in, then this one is a out. So we don't care your connection positive or negative. You see red color normally positive, is it? So the black color normally is a negative, is it? So from here, you see my connection, actually that's a correct one, is it? Positive, I join red color. Negative, I join black color. Connection is correct. So you see my galvanometer that can deflect it to the positive. That means they can read the reading. Okay. This one is a second choice, let you to see how to deflect it. First, connection is correct. Then we go to right hand side. Okay. If connection is terbalik, that means later I will show the terbalik one. Okay. You can find the galvanometer will deflect it to the left hand side. This one is the first method. Second method, you no need to see positive and negative. When you just see where the current just come, then the galvanometer will deflect it, go there. This one is a second method. We're going to find galvanometer, how to deflect it. Okay, why I say got two methods. First method, because they got current, then you can see that one is a Fleming left-hand rule because got current. If Fleming right-hand rule, there's a no current one. That means the current is never provided. You need to generate by yourself. Like this, that means we cannot using this method. How the galvanometer deflected. Okay, so we need to using the second method. Where the current just in, that means you need to deflect it, go there. Okay, we go through the explanation first. Okay, this one is a positive readings. Okay, red terminal is a positive to the positive terminal. So that's why they produce is a positive readings. Black one, negative terminal, also go to the negative terminal, black color. So of the EMF source. So from here, the positive reading, they will deflector go to the right hand side. So you can see the pointer will go to the right hand side. So you can see the arrow is the same. Current just in, the galvanometer will point, follow the current where they in. Okay, now we're going to see this one is an ammeter. Ammeter, the ammeter we cannot show about negative one. I don't know you got tried before or not. I think no lah, because you form 5 also never start about experiment. So if you join terbalik, you see I join positive, then this one I join negative. You see, if I join the wire terbalik, because this one is a direct current. If I join terbalik, that means you read the reading is terbalik one, you know. You can see this one pointer, they will go below the 0. Below the 0 means you join terbalik already. This one not alternating current. Alternating current, never mind. But this one is a direct current. So you need to follow positive, positive, negative to negative. So they start from the 0 is at the left-hand side. They don't have at the middle. So that means if you join wrong, that means they will sure go straight forward, go down, negative. Okay, if you join correct, that means the needle can be from the 0, then move up. So this one's an ammeter connections. So from here, this one red terminal go to positive terminal. So that's why the black negative also go negative. Positive readings. They will deflected to the right hand side. Okay, if the connection of the ammeter reverse, if that terbalik, okay, so we see what happened for the pointer. I cannot find the voltmeter, so I cannot find the ammeter, I find the voltmeter. So also it's the same. If you tabulate to join, you can see the pointer where they go. They go below the zero. Below the zero means negative law, is it? Same like the galvanometer just now. If they go to left hand side, means there's a negative. Your connection is tabulate. Okay, so I show you back about the galvanometer, they join reverse. Okay, now you see the galvanometer. This one is a negative terminal. I go to red terminal. So that means you are wrong already lah. Then the positive, I join with black color terminal. So this one current how to flow. Current must flow, start from the positive. Then now they go in the black point, the black negative. Then after that, they out from the red, then go back. Okay, so from here, you can see the reading for galvanometer. They will deflected go to the left-hand side. That means this one is a negative reading. Negative reading, what's the meaning? Your connection is wrong. Okay, your connection is wrong already. So from here, I can explain. Positive, red terminal, go to negative terminal. Black terminal, go to positive terminal. So this one, we call it negative reading. Galvanometer with deflector, go to the left. Okay, this one is a diagram. Okay, now if I'm using the second method, okay, we go to check is it correct or not. Galvanometer always deflected to the direction where the current is. Okay, where's the current in now? Okay, current into the black terminal. So the galvanometer deflected to the black terminal. Okay, so this one we using second method also can explain how the galvanometer deflected. Okay, then we go to determine the direction of the induced current. How the induced current to flow. Okay, by using two law. Okay, one is a rule, one is a law. Okay, rule we got Fleming right hand. Today we just focus using the right hand. Okay, another one is a Lenz law. Now we need to know where the current go. Okay, the current is either go to you or far away from you, like this only. So go to you means there's a dot. Far away from you, there's a cross. Okay, remember this one symbol. Okay, we're going to show Fleming right hand. So you point your right hand. Okay, it's the same. Okay, the pointer is the same. First one, the first finger, the forefinger, this one still magnetic field. So north to south. You can see the diagram now. North to south. Still the same. Okay, so from here, the question normally they never show the current already. They just show you the motion, how the conductor wire go to move. So if the conductor wire move up, then you point your thumb up. Okay, if the conductor is down, then you need to turn, point the thumb, go downwards. Then you take out the second finger. Now the second finger is far away from me. Far away from me. Okay, if the force is up, okay, the force is up, that means I point my second finger to my side, is it? So that means the current is cut, okay? So flexible to turn your finger. Okay, so from here, so you can find it, magnetic field still the same, current still the same, the force still the same. Just we need to know is current how to flow, okay? And know we need to using right hand. So some students will ask, when using right, when using the left. Okay, when the question, they don't have any battery. That means the whole situation, whole circuit, no battery one. Okay, they just move the conductor wire between the magnet. You see the conductor wire, they move between the magnet. So we need to using right hand. So that means we're using the right hand to generate the electricity. Okay, when the whole circuit got battery, they let you to see the current how to flow. That one is a motor. That one we're using left hand. Okay, we need to find the coin how to turn. That one is a left hand. Okay, so I show another way they can find about the induced current. That's a Lenz law. Okay, Lenz law is go in the solenoid. This one is a solenoid. Okay, the magnet move in the solenoid. Then they can generate the current. This one current we call induced current. Okay, for this one situation, you need to know the current how to flow through the coin, anti-clockwise or clockwise. After that, they will go galvanometer. When they just go galvanometer, then you need to show how they deflected. Okay, how they deflected, that means depends the current. If the current just in, then the galvanometer will deflected, go that directions. For this one situation, we do know which one positive, which one negative. So we do know they go to left or go to right. So you need to using the second method. That means where the current in, then the galvanometer will deflected, go that directions. Okay, now I go to show one by one. Fleming right hand first. Okay, used to determine the direction of the induced current in a straight wire. Okay, then we're producing of the induced current when there is a changes, or you say cutting the magnetic flux by the conductor. So this one we learned before. How to produce induced current, you must have changing, or you say cut the magnetic flux. Okay, if you never cut the magnetic flux in 90 degrees, actually you cannot produce an induced current. So from here, this one show again, thumb stand for motion. Where's the location of the conductor you're going to move? Okay, magnetic field is a 4-finger. The first finger, normally here is a north, then go up should be the south. Okay, then the middle finger, now we call it as a induced current. Okay, induced current like this. I point the laptop, means the current is far away from me. If I turn, I point the second finger to myself, means the current is come to me. Okay, now we go and see the determine the induced current for straight wire. Okay, you can see the diagram now. Okay, north to south is a permanent magnet. So permanent magnet, they will produce a magnetic field. So the magnetic field is from the north go to south, is it? So you point north to south. North to south. Okay, now we do know the current. We assume we do know the current. We know the direction of the conductor wire. Now the conductor wire, I move up. You can see the red color arrow, then move up. So that means when you move up, you take out your thumb. Your thumb is go up. Okay, your thumb is go up. So now you take out your second finger. Now your second finger, you pour yourself, is it? When you pour yourself, the meaning is the current is come to you. So you can see the direction for the pink color. The arrow is come to you. When just come to you, you continue to draw to the clip wire. Then they go to the negative terminal. Then they out from the positive terminal, then go back. So from here, now we go and see galvanometer. Where's the come to the negative terminal, is it? So your galvanometer must deflected, go to the left-hand side. Okay, deflected, go to the left-hand side. They follow the direction where the current is. Okay, so from here, we can find about the direction of the current, how to flow. We also need to know how the galvanometer go to deflected. Okay, now we're going to show the finger, right-hand rule. Then this one is a sentence. You need to know how to find the galvanometer deflections. The galvanometer always deflected to the direction where the direction of the current flow in. Okay, so from here, this one should be the negative readings lah. Why? Because positive and negative, they're terbalik. So from here, we don't have battery ma. How I know which one positive, which one negative? I also don't know. Okay, so from here, you find it. Now the galvanometer deflected to the negative. Okay, because the current flow in, then the deflector follow the current. So I know this one situation is a negative. Okay, example, if I want to assume now the conductor wire is a battery. Okay, I assume this one is a battery. So the battery sure is a positive lah here, because the positive will start first. This one should be the negative, is it? So that means positive start, I go but black color mean this one connection is a wrong one. Okay, if I assume the conductor is a battery lah. But now we don't have battery, is it? If no battery, that means we can using the second method to see how galvanometer is deflected. Okay, if got battery, never mind. We just see connection only. If your connection is wrong, sure they're deflected negative. Okay, so from here, we need to using the second method to find galvanometer, how to deflect it. Okay, now second situation. Second situation is the conductor don't move. I move magnet. Okay, I move the magnet down. Okay, I move the magnet down. So from here, they got tell you, the motion of the magnet go downwards. What's the meaning? The equivalent to the motion of the wire move upwards. That means the field now from the permanent magnet, now you go to move your permanent magnet. So you move your permanent magnet means you move down, that means the conductor is up. Okay, just like the conductor want to cut magnetic field up. Okay, so from here, this one situation also same like just now. We point by using Fleming left hand, Fleming right hand. Okay, after that, conductor wire now is moving down, same like just now, go down. Okay, because this one is go up. Okay, because the magnet is go down, then your conductor wire is up. So I just point north to south. Okay, so you take out your first finger. Okay, then the conductor wire is up. Okay, it's up. So you take out your second finger, they also point yourself. So that means the current also deflected exactly the same. So that means I don't care your conductor wire move up, magnet if move down, that's the same meaning. Okay, that's the same meaning. Okay, so remember the magnet move, they should be opposite with the direction with the conductor. Magnet move down means the conductor move up. Okay, so from here they show about the direction of the conductor actually is up. So they're still using the Fleming right hand. Okay, because some of the exercise, you need to tell me the answer. Choose the correct answer to show the direction of the induced current. Okay, this is a north to south. You see N as a north to south. So you point north to south. Okay, current, we do know how to flow. Okay, first round, okay, we see the A. They say moving the wire, move up. Okay, I move up. Okay, now you take out your second finger. Second finger is point to you or far away from you. Okay, I want to ask Esther.
Yes, teacher.
Okay, now you tell me the current is come to you or far away from you for the second finger. Okay, you point north to south. You take out your thumb. Thumb is point upwards. Okay, you take out your second finger.
Come to me.
Come to you. The second finger point yourself or point your laptop?
Laptop.
Point your laptop like this. You show north to south. Okay. Then after that, you take out your thumb. Your thumb should point up, is it? Right hand, Then you take out the second finger. The second finger point where?
Point me.
Point yourself, is it? Point yourself means the current come to you, is it?
Come
to you is YZ or YX or XY? You stand here, you stand here, you stand here. You stand in front of the X. So the current, how to come? Y to X or X to Y?
XY.
Come to you. The current come to you.
Oh, YX.
Come to you means the arrow go yourself, you know. Okay, so the answer must be YX. The current come to your side. Okay, if the current come to your side, that means I can draw the arrow from the Y, go to the X. After that, the X go to the galvanometer. Okay, here is the current in. Okay, so this one galvanometer, you cannot see left or right because the two pointer also there. Okay, this one is out, this one is in. Two direction is the same. So from here, we cannot see which one direction they want to deflect it. Okay, so from here, this one, we cannot talking about this lah. I don't know, this one is galvanometer or ammeter lah. So from here, we just want to know is current how to flow, Y to X. If terbalik, okay, if terbalik, sure you know lah the answer, but I want you to show how to point. North to south, this one a little bit harder. Your second finger now is your thumb. Now want to turn to south is the same. Okay, now you go to turn, rotate. Rotate your hand, go down. Okay, now like this already. Okay, the thumb is go down. Thumb is go down, you take out your second finger. Your second finger now is point the laptop. Or you point me, lor. In your camera there, then you point me, lor, is it? Now, my one is point to the computer. Okay, far away from me. So far away from me means I stand in front of the X to Y. Okay, now the current is X, go to Y. So that means now the current will go in the red color point, then pass through this one, don't know what meter, then come up from the blue, then go to the X. Okay, so this one is how the current go to flow. Okay, by using the movement. Movement means cut the magnetic field in 90 degrees. After that, they produce an induced current. Okay, now we got second diagram. North to south. You can see the hand now a little bit hard because you need to point like this. You point to right hand side. Okay, use your right hand, point to right hand side. Okay, first finger you point to right hand side. Okay, after that you take out your thumb. Okay, first round the conductor wire move upwards. You point up. Okay, where is the second finger? Take out. Okay, second finger now point the laptop far away from me. Okay, far away from me is A to B. Okay, if I stand in front the A, so that means there's a far away from me, the current from A go to B. Okay, if the ballet hard a bit, you need to rotate. Okay, you need to rotate. Okay, rotate already. Then take out your finger. Then the finger is point yourself. Point yourself. So that means B to A. So I just show. Okay. So hopefully you know how to rotate your finger, your hand. Moving the wire upwards. Moving the wire upwards. Just now you show moving, same like this one diagram. Moving the upwards. This one is force, motions. Okay, then this one is your magnetic field. So you see the current is far away from you. So should be A to B. Okay, if the ballet should be B to A. Okay, should be B to A. Okay, so from here we go to the next. Okay, this one again. Okay, this one situation we also we know the current. I'll show you the current. Okay, but the question is we don't know the north and also the south. Okay, we do know the north and also the south. So that means you need to show where's the north, which one is the north, which one is the south. So that means the first finger you cannot point first, Okay, you want to point is okay. Later you go to rotate back. Okay, first the thumb is go down. Okay, you show the blue color, the movement is go down. Okay, the current how? The current is far away from you. Point the second finger far away from you. Take out your first finger. So I find it the situation like this. Go downwards, the motion. Then the current far away from you. Then I take out my first finger. My first finger is point to the left hand side. Okay, left hand side means what? This one is a north. This one, my tip finger, this one is a south. North, south. North, then this one south. Okay, so this one is a Q. This one should be the P. Okay, now the question they ask you, what's a P? P is where? P is this part. Okay, this one is a south. Q is what? Q is a north. Okay, I go to answer. P is a south. Q is a north. So the question then can be terbalik to us. Not just asking about the current. They can ask about the magnet. So for this one situation, you sure we know using right hand because no battery. What? The whole circuit where got the battery. No battery supply means we need to using the right hand already. Okay. Okay, let's see the activity 4.13. Okay, from your textbook. They want to indicate the direction of the induced current in the solenoid by using Lenz law. Now we're going to see Lenz law already. Okay, Lenz law, what they're talking about. Okay, this one's a definition for the Lenz law. Okay, Lenz law, they state about the induced current, they always flow in a direction that opposes the chain magnetic flux that cause it. Okay, they just want to mention how the induced current produced. The induced current produced when the magnetic flux is in opposite directions. Okay, the flowing direction in opposite. Then after that, they produce changing magnetic flux. Okay, what means the opposite directions? Okay, let's see here. This one is a solenoid. Then the magnet you want to put in. This one not related with the Fleming right hand. No, this one is a Lenz law. Okay, Lenz law also say they can produce induced current. Okay, they say what? When the magnet they want to put in, okay, they produce one opposed force. That means the force is the opposite. Okay, then after that, they also can change the magnetic flux when the magnet just go in. So that means when you just in, they produce one of the force. Okay, this one force, we can say repulsive force, you can say attraction force. Okay, but when you just push the magnet in, sure can in because you produce the energy you push, is it? For in, they can produce one of the opposed force. Okay, because of this one opposed force, then we know the current how to flow. Okay, they got opposed force, then they produce induced current. Then after that, you go in, sure cut the flux, is it? Because the magnet got flux, now you got number of turn. So when they just in, they cut the flux, that means the current know how to flow. Okay, so from here they say when the end pole of the magnet, this one is the end pole, they move towards the coin. This one is a coin. The end of the coin will become end pole. So that means they produce the opposed force. Okay, what's the opposed force? Means you want to come in, I don't let you to come in. This one we call opposed force. So this one is a repulsive force. If you put N go in, if I hear it's a south, that means you come in already, is it? You got north and also the south, they want to attract. So from here, they will automatically produce one repulsive force. So they become N. So when here become N, then here sure becomes south. Okay, so from here, because of north and also the south, then we know how the induced current to flowing. Okay, how we know the induced current to flowing? We just talking north and south only, but we still do know current how to flow, is it? Okay, now I want to recall back this one. Okay, the magnet, remember the magnet, north to south, the direction of the magnetic field sure come out from the north, go into the south. Okay, this one also is a solenoid. Solenoid, the magnetic field same like the magnet bar. Also same, current out, the direction of the magnetic field out from the north into the south. Okay, the pattern should be the same. Okay, now I want to introduce this one. Okay, I want to take one pen first. My pen very slim. Okay, marker pad. This one highlight pad. Okay, this one just like the cone. Then after that, I got not turning. So I go to grip. I use my right hand. This one using right hand grip. Remember this one right hand rule. Then this one we call right hand grip. Okay, now I go to grip my marker. Okay, I grip my marker. So when you just grip the marker means where the thumb show, that one is a north. Where the thumb show, there's a north. Okay, I show you back just now the diagram. Okay, this part we already locked, there's a north, is it? Okay, because we follow the Lenz law. You want to go in, I don't let you to go in. So this one is an N. So this one is a south. So I how to grip. Okay, now it's a solenoid here. Solenoid is turning the highlight pen. So now north is left hand side. So I need to grip by using right hand. Thumb show north. Sure is a north. Then the finger show current. Now I go to show my thumb is the left hand side. I go to grip. Okay, I go to grip. So now my thumb is go to left hand side. Okay, how my finger? My finger is grip like this. Okay, you can see the arrow is the same. The black color arrow is same like my finger go to grip. Okay, so from here I go to grip. Okay, so I continue lah. The black color I go to label. Okay, the current is up because I grip like this, up. So when this one up, it's all is up lah. So until here the turn will go down. Okay, then this one will go up. So galvanometer, how to deflect it? Follow direction of the current in. The current just in, then the galvanometer will deflect it to the left hand side. Okay, so this one we call Lenz law by using the right hand grip. Okay, right hand grip. Thumb represent north. Finger represent current how to flow. Okay, this one is the first we know how the current flow. Number two, you also can know current how to flow. Okay, north pole. North pole, if I say left hand side is the north pole, you can see the current flow. That's an anti-clockwise. Anti-clockwise. That means you stand at the end, you can see the current flow anti-clockwise. If you stand at the south, you can see the current flow in the clockwise. Okay, I can show you the detail later. So you can see this one grid. Can you see the diagram grid? Okay, they're just like one of the rod. Then I go to grip. Okay, I go to grip. Okay, you can grip like this, you can grip like this. Important, the thumb is go to left hand side. Okay, when you just grip, then you see the current, how to grip. The current is go in, then come out. So that means if you stand at the end here, you see the current actually is an anti-clockwise. If you stand as an S, that means it's a clockwise. So from here, you can see the north pole and the south pole can also be determined by using the right hand grip. This one we call right hand grip. Okay, then they show by following diagram. Okay, I show you this one. If you stand here, your eyes focus here, you can see the X. X is what? X is clockwise. Okay, if you stand Y, that means you see the X is a anti-clockwise. So anti-clockwise sure is a north pole. Okay, clockwise sure is a south pole. Okay, so from here, I show you another diagram. Okay, now the magnet want to out. They want to out. Just now it's in. Now it's out. Okay, when they out, follow Lenz law. They got one of the opposed force. Don't let you to out. Just now you want to in, is it? I don't let you to in. Now you want to out, I don't let you to out. Okay, if I don't let you to out, mean this one solenoid must be south pole. Because south pole, you want attract the end come back, is it? So from here, this one is an attraction force. Just now it's a repulsive. Now it's an attract. So this one is a supply, is it? So how you find the current, how to flow? Take out your grip again. Right hand grip. Point the north. Now the north is the right hand side. Okay, how your finger grip? Your finger now is grip. Okay, grip come to you. So I point I put my finger, the highlight pen here. I go to grip my highlight pen. Thumb is go to right hand side. Okay, so the finger represent the current. They will grip come to yourself. So you can see the black color or it's a current point to yourself. Okay, when the current just point to yourself, so the current will start from the right hand side, go in galvanometer, out from the left hand side and go up. So the galvanometer, how to deflect it? Follow the direction of the current in. Where the current just in, they'll deflect it, follow the direction of current in. Okay, so from here, when the end pole of the magnet is moved away from the coil, end of the coil will become south pole. Okay, so this one is a related for the Lenz law. Then they produce induced current. Okay, so if they never mention this all thing, we do know which one is a north, which one is a south. Then you cannot find the current, how to move. So important is Lenz law. They told you they got opposed. Remember the opposed. You want to in, then I need to see magnet lah. You N or S want to in. If you N want to in, I don't let you to in. If I don't let you to in, sure I'm the north law. If you south want to in, I also don't let you to in. So I must be south. Okay, remember this one concept. Want to in, don't let you to in. If you want to out, I also don't let you to out. I want you attract, you come back. So this one is a Lenz law. Okay, so from here, they got one of the exercise. Okay, now you need to tell me the answer. Okay, I want to move the north pole. Now north pole. Okay, I want the towards to the A of the solenoid. Okay, I'm going to go in the A. Now you tell me the A is north or south. Okay, I'm going to ask. I'm going to ask who? Okay, ask Sharon. Sharon?
Yes, teacher.
Now the north, they want to in. Okay, you tell me the A. A at the solenoid here. A is what? South or north?
South, teacher.
South. I want to in or not out, you know.
North.
North, that means you got something don't let you to come in. Okay, if north and north, that means you are repulsed, it? So that means there's an opposed, don't let you to come in. So now A is a north pole. If you want to in, okay, now the question say they want to in. Okay, so from here, if I know the A is a north pole, so I grip. Okay, I point, left-hand side is a north, then I go to grip. Okay, when I go to grip, that means all the current will become up. Okay, become up. So the current go to the black terminal. Then this one will flow out. From the red color, they will flow up. So all the current at the solenoid is up. Okay, so from here, I need to know direction deflection of the galvanometer and also the magnetic polarity. Just now, Sharon told me there already is a north. Okay, now I need to know direction of the galvanometer. Jia Yao, deflected left or diffracted right?
Left.
Left. Okay, because just now we say current is up already, is it here? Until this part, they will come down. So come down, that means the current in the black terminal. So the galvanometer sure will go to the direction of the galvanometer, direction to the current one. So current just in, they will follow. So from here, you can find they go to the left. Okay, second one, that means you away. Now the north, you want away already. Okay, you want to away from the A. That means the A will produce one of the force. Don't let you go. Don't let you go. Don't let you go means A will become sub. They will attract the north come back. Okay, so after that, they also will make the current changes opposite direction already lah. Now, where the current just opposite direction means the deflection also opposite direction. They will go to the right hand side. Okay, this one just Lenz law. Never mention about Fleming. Okay. Okay, now the another situation is the same thing, but now it's a south. South want to go in. Okay, south want to go in. So I want to ask Yiru. Yiru,
Yes, teacher.
S want to go in. Now you tell me the A should be
North.
north. North me attract already. I want to go in or follow Lenz law or
Oh, south.
they must have something don't let you to go in, oppose. So that means the A must be the south because they don't let you to go in. Okay, if they don't let you to go in, this one is a south, another side should be the north lah. So you need to point the thumb go to right hand side, then the current is grip to your. So when you draw the current, you grip to yourself, the current will down to the red terminal, out from the black terminal. So if the current is go to the red terminal, so the galvanometer will deflected to the right hand side because they follow where the current in. So the right hand side. So when the south, they want to out, they got one of the force want to attract the south come back. Okay, so they will produce north. Then this one will go to the left. Okay, this one you must very, very clear, you know, because during the exam, the sure will come up. They call you to draw the direction or the galvanometer, how to deflect it. Okay, so this one is a Lenz law. Remember, magnet want to in, solenoid will produce opposed force. Don't let you to in. So if N want to in, they sure produce N. So that's why you cannot in. Okay, suppose you can in because when starting, they got one of the force lah. If your hand still push, they sure can go in one. If not, cannot cut the flux one. Okay, if you want to out, north want to out, then the solenoid must produce one of the force. Don't let you to out. So if north want to out, don't let you to out means what? They want to attract the magnet come back. How you attract the magnet come back? You must produce south. Then you can attract the magnet come back, is it? So that's why they also can be out. They just got one of the force you need to overcome. So you need to push harder. Okay, so this one is how Lenz law they're talking about. Okay, so from here, this one explain for you. Okay, now the N they want to go in. Induced current produce a north pole. Okay, to oppose the motion of the magnet coming towards the solenoid. So from here, when the magnet just move towards the solenoid, there is a force, repulsion force. So exit between the solenoid and magnet. So from here, the end of the P, this one P, is induced to become north pole. Okay, the force become north pole. So from here, the direction now the current is in clockwise. Okay, direction of the current in clockwise. Okay, clockwise. I also don't know how to take it. Okay, don't go and see the clockwise first. I want you to see the focus, your hand, how to move first. This one is north, then north. And this one is a grip, your electric current, how to grip. Okay, after that, the galvanometer always point where the current come. The current just come from the left-hand side, then the galvanometer deflected to the left-hand side. Help me to ignore the second sentence. Only the P is a north. Only the P is a north. Okay, direction of the current is clockwise, you just ignore. Okay, then after that, you need to know the deflection of the galvanometer. Follow direction where the current comes. That's all. Okay, question. What happens when the magnet is pushed towards solenoid? Okay, when it just push it to the solenoid, then we know sure cut magnetic field lah. So they cut the magnetic flux, galvanometer pointer deflected, and induced current produced. So when it just in, they sure we cut the flux lah. After that, the current can flow through the circuit lah. Then the galvanometer will deflected lah. Okay, so this one is a situation when the magnet just in. If the magnet out, okay, if the magnet out also got induced current, can induce produce a subway. If you want to out, I produce one of the force. They want to attract the magnet come back. So from here, the magnet will move away from the solenoid. There is a force. What force? Attraction force. Exists between the solenoid and also the magnet. So from here, the P now become what? South pole. Okay, the P becomes south pole. Okay, again, the second sentence don't come and don't see the anti-clockwise, don't see. You just see the thumb. Okay, now the thumb is go to left hand side because your north is left hand side, south is the right hand side. So you go to grid, then like this. Okay, you can see the arrow, all is up, then grid, go up. So the current is down, then go A to B lah. So you can from here, galvanometer will deflected to the direction of the current. So now the question state the direction of the current. Current will flow from A to the B. Okay, direction, deflection. This one from the textbook. If you don't understand, you need to recall back. So the north want to go in, this one sure become the north. Okay, then you point your finger, right hand side, then north. Then you see the current is come down. Okay, when the current just come down, you continue to draw until the wire join with the galvanometer. When the current just in, okay, then your galvanometer must deflected to the left hand side. Okay, so this all thing I don't want to repeat already. So that means you need to read by yourself or your textbook. Okay, I want you to answer me for this question. Okay, diagram show about the straight wire, copper wire. There's a connected galvanometer. You see no battery. There's a move vertically downwards in the magnetic field. Now the wire is moved down. Then wire is moved go down. Okay, mark the direction of the induced current that flow through. Okay, now you tell me the current is come to you or far away from you. Okay, I want to ask the student Tan Junsen. Tan Junsen?
Yeah, yes.
The current is come to you or far away from you? Right hand.
To me. To
you.
Ah.
Okay, now we go to show. Yeah, current is come to you. You point north to south. Then you take out your thumb. Okay, your thumb should be point down. Point down already. Take out your second finger. Your second finger should point yourself, is it? So then the arrow is come to you. Okay, name the rule we use. Okay, Siti, what's the rule we use it? Khatijah? Siti Khatijah?
Yes, teacher.
This one, the current come to me, we using what rule to find it? The Fleming?
Right hand rule.
Yeah, the Fleming right hand rule. Okay, now you need to describe. Describe the effect of the induced current if the wire is moved vertically upwards. Change already. Just now it's downward. Now I move upwards and also low speed. Low speed. Okay, so the wire move vertically upward, low speed. We need to describe the effect of the induced current. First, induced current sure move opposite directions because you already turn the motion is up. Low speed, sure the current is a less one because your speed becomes slow. Okay, so from here, opposite direction of the current and smaller current. Okay, now second time, the wire move vertically up, also up. Up means opposite direction already. high speed. So you just change current, now is a bigger current. Okay, they produce larger current already. Third, the wire now stationary between the pole and magnet. Okay, now you tell me what happened for the induced current. If you just stationary, that means you never cut anything, you know. Never cut anything means what? No induced current to produce lah, because you never cut what? Why my camera disappeared here? Okay, wait Oh, can see it. Okay, go to show. So from here, the third one, no current flow. Because you are stationary, you never cut the magnetic field. Okay, so this one, I don't want to do. Okay, I want to let you to do. You go to snap photo. For the student, you're using the handphone, you go to print screen. For the student, you're using the laptop, you use your handphone, go to snap example 2. Okay, so you need to do by yourself. Then you need to do by yourself. Then after that, what you need to do? After that, you send the photo to me. After you go to finish, you send the photo to me. Okay, you just label only, use your hand. If you're using handphone, you just draw the arrow how to flow, then you draw the galvanometer how to flow. Okay, for the student, if you're using your handphone to snap, you also can be using your hand to touch your handphone, is it? So you go to edit by your handphone, and you show me the current how to flow, and galvanometer how to deflect it. Then you show me north and also south. I show you first one. Okay, when you want to go in, this one produce north, this one produce south. Okay, so use your thumb, right hand grip, north. Okay, so the current grip like this. Okay, I show the current how to grip. Okay, third, the current flow the circuit. Okay, where's the current come? The current is come from here. Okay, go in the galvanometer. So the deflection go to the direction of current in. Okay, so this one is the first answer. You show me the second, third, and also fourth. Okay, can So I want this one as your exercise today. You need to pass up to me. Okay, PM me in telegrams for the diagram. Everybody got the module. Then you need to do is this one is a chapter 4.2. Okay, 4.2, you go to find out the objective and also structure how to do. The answer I will give you one if you just finish. Okay, the whole topics. Okay, after that, I got, and today don't have any Google form. You don't need to fill in the Google form because attendant just now they snapped the photo already. So my lesson just until here only. So you know just now how to flow the current using the right hand rule. Okay, so just like this, my lesson just until here. So everybody, hopefully today you go to practice your hand, right hand, and also the right hand grip. Okay, thank you for your joining my class. So now you can release, go to your another class already. Okay, bye everyone.
Thank you, teacher.
Okay,
Thank you, teacher.
bye.
Thank you,
Thank you,
teacher.
teacher.
Thank you,
Okay,
teacher.
bye.
Thank you, teacher.